Hey guys, Mr. Zigner, we're going to be looking at congruent figures today. So you can see here, two figures are congruent when they have the same size and the same shape. You may have heard the term similar before. Similar means the same shape, but congruent. Today's topic is same size and the same shape. Here you can see these are congruent. It doesn't matter if one's turned and differently than the first, as long as they're the same size and shape. But they're not congruent if you have maybe, say, the same shape, but two different sizes. All right. So, sort of what I was just saying, figures that have the same size and same shape are congruent figures. You have matching angles. Those would be called corresponding angles. So like here, if I slid this triangle over on top of this one, angle B would correspond to angle E. Do you see that? If I slid this right over on top of this one, angle C matches up with angle F. So they're corresponding. Oh, they even color coordinated them for us. And here, this blue angle A, if we slide the triangle over, would be right on top of angle D. Okay, now the matching sides between the two shapes are called corresponding sides. So here you can see this green AC would correspond with the green DF. BC up here in blue would correspond with EF. And finally, AB here in red would match up with DE right here, also in red. So that's corresponding angles and corresponding sides. And looks like this is more the same thing, but they're just further elaborating on it. So identifying congruent figures, two figures are congruent when the corresponding angles and corresponding sides are congruent. So we need to make sure that all the sides have a corresponding side. So here BC matches EF, DF matches AC, and AB matches ED. And the angles have to correspond, meaning they're the same exact measure. So here, angle A, notice the three little curves or arcs, and this one has three also. That means those two are the same measure. Here, one little arc for B matches one little arc for E. That kind of makes sense. It looks like that would land right on top of it and be the same exact size. And angle C has two little arcs, and angle F has those same two arcs, indicating they have the same measurement. So once you've determined the sides are all corresponding and the angles also are corresponding, then you can say those two triangles are congruent. And this is the symbol for congruent. You have an equal sign with a little wave above it. So that's the symbol for congruent. And we have triangle. ABC is congruent to triangle DEF. Okay, so are the triangles congruent or not congruent? Well, right away, I hope you're seeing it. This second triangle, they look similar in shape, but the size is wrong. And I even traced over top of that one. Now, well, that doesn't work very well. Let me try turning it. And now sitting on top of this one. And as you can see, yeah, pretty darn close to the same shape, but definitely the wrong size. So we would say, let's see, what congruent, not congruent. So not congruent. Just going to abbreviate that to shorten the video up a little bit. And now we'll look over here. What about these two? Well, again, if I take what I traced on the second triangle, let's turn that around. Does it sit nicely, perfectly on top of the other one? Yeah, that looks pretty good. So we would say that yes, these two are congruent to each other. They're the same size and same shape. All right, beautiful. Moving on. These figures are congruent. So name the corresponding angles and the corresponding sides. So here's how that looks. So how about we start with what they mentioned first, angles. We'll work our way alphabetically. So we could say that angle A and now let's see, what would correspond to angle A? If I were to slide this one down and sit it on top of this one, looks like A would correspond to J. So angle J. B, slide down here right on top, would go with K. So angle B and angle K. Now here's C corresponds to L. I'm just using a little, almost looks like a less than sign, but it's an angle symbol. And finally, angle D, and coming right down here, angle M. So that's the corresponding angles. Now, what about corresponding sides? Well, let's go through those. We have AB. So we have AB. And now let's see, that's a line segment. Someone use a line segment symbol above. Now, AB would go with JK. So AB and JK. All right. BC. And let's see, BC is vertical right here. That would match with KL. CD and LM. And finally, DA would correspond to MJ. A little silly and symbol. And then we would go through all the same thing here. Let me just talk about a couple of these. So the interesting thing with this one is that, you see, it's almost like it's a mirror image. It's a reflection. So let's just pick out a couple of these. I'm not going to do all, let's see, all 5 of those. Let's, how about angle P? Can you figure out here real quick? See if you can figure it out before I say it. What angle corresponds with angle P if we reflect this over, kind of like a mirror image? Do you see it? It's right here, angle W. So angle W. Let's do one more. How about angle S? Angle S. So that would be angle Y. Again, you have to see that this one is a reflection of that one. So T would go with X, R would go with Z, and so forth. Let's do 1 or 2 sides. How about PT? So what about PT? We'll do 1 or 2 of the sides. PT, and what would correspond to PT? Well, that would be WX right over here, sort of right across from it. So that was WX. Maybe one more. How about SR? SR right here at the bottom. SR, and can you guess it before I get to it? Over here, well, that would be right along the bottom here. Flip it over, and that would be YZ. There we go. So that's not all of them, but that's the idea of how that works. Are the two, tell whether the 2 figures are congruent and explain your reasoning. Okay, if you remember from the previous slide, you have to have the same exact side lengths, the same exact angles. So that you have to have corresponding angles and corresponding side lengths. Well, let's see. We have a 6 here and a 6 here. That's good. 10 and a 10. Great. An 8 and an 8. We're looking good. Let's just check the angles. I have a right angle right here. Another one here. One little arc here. One little arc here. That means those 2 are the same measure. And 2 arcs right here and 2 arcs right here. So those match. So we do have corresponding angles and we do have corresponding sides. So the answer here is yes. And as I just said, I'm not going to write that out to shorten the video, but my explanation is we have corresponding sides and angles. So there we go. Now what about here? Okay, we have 2 rectangles, so it looks like another yes, right? Well, it turns out it's a no, but actually I think I need to move my picture here to show you why. And do you see it? Even though we have rectangles that have 90-degree angles, the problem is the side lengths. We have side lengths of 15 and 10 versus here we have 12 and 8. So this is no, they're not congruent. They might be similar. You'd have to test that, but that's not in this video. But and then I guess the reason why we're saying that is the side lengths are not corresponding. Oops, that was supposed to be an R, A-R-E. Well, we could say the side lengths are different. Or the corresponding side lengths are different. Something to that effect. We would definitely see that with those different side lengths, that immediately causes it to not be congruent. Again, it might be similar, but that's another lesson. We won't get into that today, but they're definitely not congruent with those different side lengths. So it has to take the angles and the side lengths to be congruent. Moving on. Okay, so describe and correct the error in telling whether these two figures are congruent. Let me scooch my little video down that way. All right, well, we have all side lengths of, all side lengths of 6 here and all side lengths of 6 here. So we're looking good so far. And it says both figures have 4 sides. Well, that's true. And the corresponding side lengths are equal. Well, that's true. So they are congruent. Oh, do you see the problem? They may both have 4 sides, but that's not really the super important thing. I mean, it's important that they do both have the same number of sides, but the side lengths is not enough. We also need to see that the angles are corresponding. And truly, this looks like a square. Now we have to check, but no, this is definitely not a square. And the angle measurements, these two are the same, and these two are the same, but they're not going to be the same as this one right here, or it would have the same little single marks and these double marks, little arcs here, and those measurements aren't shown over here. So we would say they're not. They're not congruent. What can we say here? The angles, the corresponding angles are not the same. Can't spell. Are not the same. Not the same measure. Might be a good way of saying that. Okay, so again, we have the side lengths, but we don't have the angle measures being the same. And both those have to be in place if we're going to call them congruent. If that's not there, then we can't call them congruent. Alrighty, so we have the front of 2 of the houses are identical. Okay, well, they look like they're the same exact thing. What is the length of LM? Okay, so this is going to be a little bit of look at the one, then look at the other, and try to figure out some missing measurements. The length of LM. Okay, well, here it is. It's along the bottom below the door, the bottom of the house. Well, if, excuse me, if the houses are identical, then it would have to match the bottom here. So since CD is 32, then LM would also have to be 32. And what are we measuring in? Feet. Okay. Which angle of JKLMN, so this one, JKLMN, corresponds to D? Okay, so D is the bottom left angle here below this left window. So let's come to the same spot on the house down here, and there it is, angle M. So M, the bottom left angle here, corresponds to this one down here. Side AB is congruent to side AE. So AB right here is congruent, meaning the same length as AE. Oh, okay. So these two are both the same length. All right. So if I call this X, then this would also be X. But I don't know how long it is yet. It says, what is the length of AB? Okay, well, how do we figure that out? They didn't give us either one of those. They just told us the two of them were the same length. Wait, we can come over to this house, which is the identical measurements. So if this is 20 feet, well, then this is 20 feet. Okay, so how long is AB? Well, AB must be 20 feet. And we picked that up from the other house, which is supposed to be identical to it. What is the perimeter of ABCDE? Okay, ABCDE. Well, what numbers do we have? Let's see, we have two 20s. So 20 plus 20, two 12s, 12, 12, and a 32 on the bottom. Okay, so let's see here. 2, 4, 6. Nothing to carry. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go, 96. And we're measuring in feet. Beautiful. Okay. All right, we have our two shapes here. The trapezoids, yep, these are trapezoids, are congruent. Okay, they're telling us up front these are congruent. Great. Determine whether each statement is true or false and explain your reasoning. Okay, great. So AB is congruent to YZ. Is AB congruent to YZ? Well, again, I don't know if you saw it, but I traced this one again just to check. So it looks like if you flip it over, or I'm sorry, the word is rotated. That's not actually flipping. That's a rotation, what I just did. Perfect. Sits right on top of it. So yeah, this short side right here, when you rotate it 180 degrees upside down, it matched up with YZ. All right, super. So let me scoot that out of the way. So is AB congruent to YZ? Absolutely, yes. Explaining our reasoning, well, if you rotate ABCD 180 degrees so that it was upside down, AB would correspond to YZ. All right. Is angle A congruent to angle X? Is A right here congruent to X right here? Now that's interesting because let me bring my picture back here. Let's see here. So it's this top left angle. So if I bring this down, this top left angle, keep your eye on this spot right there. If I rotate that around, do you see what happens? It actually corresponds to Y. So actually it doesn't correspond to X, but there's something else about this problem. They said, is it congruent? They didn't say does it correspond to it? Actually, so part C, I think we just figured out. Part C is no, because A, when you flip it around and do that rotation that I did, actually corresponds to Y. So that would be our explanation. You could say A corresponds to Y. Those two are corresponding. But B said congruent. That just means, is it the same measure? So that's a different thing we have to figure out. Well, all quadrilaterals, four-sided shapes, their angles add up to 360. So let's see here. If this angle B is 140, then if we rotate it around, then Z is 140. Now let's see, what does all this add up to so far? So we have 140 plus this 40 plus this 90. Okay, so 0, 0, 0, 9, 10, 11, 12, 13, 14, 15, 16, 17. That 270? Yeah, 270. So we had to carry the 1, sure. Okay, 270 degrees. So we know that quadrilaterals add up to 360. So 360 take away 270, well, that's 90. Okay, so it looks like angle X, which we already knew was 90 here. This is 140. This one's 40. We know this is 90. So whatever's left over, and we got 90, must be this angle right here. So angle A is 90 degrees, which means when I rotate it around, that means angle X must also be 90 degrees. Okay, so they are congruent. How about that? So yes, they are. Now explaining that would be, well, since quadrilaterals add up to 360 degrees, in ABCD, the missing angle of 90 degrees matches the missing angle of 90 degrees in the other shape. Perfect. Okay. Hey, well, thanks for joining me today for a look at congruent figures. If you enjoyed the video, as always, just like, comment, subscribe before you head out, and we'll see you next time. Thanks a lot, guys. Bye-bye.